Today we'll be looking at the concept of impulse of a force. What is this impulse? Is that huge force received by an object within a very short time interval. Let me give you an illustration. Assuming a car is moving with a very fast speed, and maybe because of the negligence of the driver, suddenly hits a nearby wall or tree or any object around. That huge force received by that object, being it the wall, the tree, within the short time interval is what we call the impulse. Remember, in one of our classes, we mentioned Newton's laws of motion. The first law, which states that an object will remain in a state of rest or uniform motion unless it is acted upon by external forces. The second law states that the rate of change of momentum is directly proportional to the applied force. And the third law states that for every action, there is always a reaction in the opposite direction. Because that they were particular about the second law. Many students of physics always state that F is equal to ma. So we derived this formula from the Newton's second law of motion. But today we'll be looking at it in the perspective of impulse. Assuming this is the mathematical statement of Newton's second law of motion, that F is equal to the applied force is directly proportional to the rate of change of momentum. This is what we call acceleration. Because we define acceleration as the rate of change of velocity. This is what we call the final velocity and the initial velocity. V minus u is what we call the change in velocity. So if instead of writing this way, we say that m v minus u all over t, and we cross multiply it, we can say that ft is equal to m v minus u. This is the change in momentum, and this is the quantity called impulse. So we can say that ft is equal to I is equal to change in momentum, which we can write as I is equal to m change in v. The difference between the final velocity and the initial velocity is what we call the change in velocity. So we have a problem here to solve. A batsman knocks back a ball straight in the direction towards the bowler without altering its initial speed of 12 meters per second. If the mass of the ball is 0.15 kg, calculate the impulse of the ball. It is simple. We simply appeal to this formula, impulse so where u is equal to 12, meters per second, and they say he hits the ball without altering its initial velocity. If the ball is coming, hitting it is going in the opposite direction. So in that case, V will now be minus 12 meters per second because the initial velocity is not altered. So from here, mass is equal to 0.15 kg. So we can say that impulse is equal to 0.15 into minus 12, which you can say 0.15 times minus 24. Minus 12 is minus 24. So we can say that impulse is equal to 0. If you multiply this, we have 3.6 Newton second. One will ask, assuming you are in an exam where calculator is not allowed, how do you navigate from here? We know that 0.15 is the same thing as 15 over 100 times minus 24. No, 5 can go here, 3, 5 here, 20. So you have 3 times minus 24 all over 20. So we can still reduce this using 2. 2 into 20, 10. 2 here, 12. 3 times minus 12 all over 10, which is minus 36 all over 10, which is minus 3.6. So if you are asked to calculate impulse and time is not involved, this is the formula that we use. But if your time is involved, consider impulse is equal to Ft. In that case, force and time